Okay, so what we've covered so far is when we had a quadratic equation. So it didn't matter if it was in function notation or if this was y equals, but if I had something like x squared minus 2x minus 8, we've talked about how we can factor that in order to solve it. Okay, so if I'm going to solve it, I want it set equal to 0. So I make the function value equal to 0. And then does that factor?
No.
It sure does.
Oh.
Okay, that's going to factor into x minus 4 and x plus 2. And then I take my factors and I set them equal to 0. And I would say x equals 4 or x equals negative 2. So we were able to solve a quadratic by factoring it, right? That's where we're at so far. Now we took some time off to do some work with some radicals, and you're going to see why today. But this is what you've done so far. This is what you've quizzed over.
Oh, wait. Oh.
All review. You should be able to finish that out. That's all review. Today, you are going to look at equations like maybe x squared equals 25. Now, I could move this over and set it equal to 0, and I could factor it. But a quicker way is to solve using square roots. Now that we understand how radicals work, if I'm trying to solve for x and I'm trying to get x by itself, I can undo squaring by taking the square root of both sides. To take the square root of x squared leaves me with just x. On the other side, when I take the square root of 25, okay, we have been writing down 5. Now, when we solved by factoring, how many answers did we get? 2. And there's actually 2 answers when you take the square root. When I take the square root of 25, I could actually get plus or minus 5. When I square a negative 5, doesn't it still equal 25?
Yeah.
Yes. And when I square a positive 5, it equals 25. Now on the 9-3, when we did 9-3-1, 9-3-2, 9-3-3, we only worked with what we call the positive root, the principal root. So we only worried about the positive answer. But there were actually 2 answers each time, plus or minus.
So,
If I were to take that original equation that I gave you, and all you knew was how to factor, you don't need to write this down. But if all you knew was how to factor, you would move the 25 over, and you'd set it equal to 0. That was one thing we had to do when we were factoring. We had to have it set equal to 0. This actually does factor. It factors into x plus 5 and x minus 5. That's why you don't see a middle term, because these are the same with just a different sign. So if I set this one equal to 0, I get a negative 5 out of that. And over here, when I set that equal to 0, I get a positive 5 out of that. So yes, we would get 2 answers by factoring, and we account for that when we use the square root by always saying plus or minus. There's always 2 roots. Does that make sense to you?
Mm-hmm.
Okay, keeping that in mind, the reason that we had 9-3, why we spent some time there, is when you take the square root, or for example, if you have an equation where it's x squared equals 12, we're going to use square roots to solve. We don't need to factor it. So we're just going to take the square root of both sides. The square root of x squared is just x. Now on the other side, we have the square root of 12. Okay, that's not an integer, right? That's not a whole number. So we're going to simplify that. We've got to say, okay, 12 is 4 times 3, and 4 is 2 times 2. So I'm going to say my answer, slide this down a little bit. The 2's are going to come out, and the 3 has to stay under. We are going to simplify our answers. So I would say plus or minus 2 square root of 3.
Ah.
Please. Really slow. I'm so sorry.
Here's an example of x squared equals 27. So I can solve this by taking the square root of both sides. Square root of x squared is just x. But I would need to simplify this. I don't want a decimal. Don't give me any decimals for answers. I want you to simplify that. So 27 is 9 times 3. 9 is 3 times 3. So I would say my answer, it's always plus or minus when you take the square root of something. So I'd say plus or minus 3 square root of 3. X squared equals a negative 16. When I attempt to take the square root of this, can I take the square root of a negative value?
No.
No. There's no number that you can take times itself and get a negative answer. Positive 4 squared is positive 16, not negative 16. And negative 4 squared is also a positive 16, not a negative 16. So this we would say is undefined, or we can't do it, not possible. Okay, we cannot take the square root of something negative. At the very beginning of Algebra 1, we talked about real numbers. And real numbers broke into sets that either were rational or irrational. Okay, you're seeing some values that are irrational. And the question I always get is when I say these are real numbers, then people say, well, what's not a real number? Well, this is actually, you'll learn this in Algebra 2, this is actually an imaginary answer. We have a whole set of numbers that are considered complex or have an imaginary part to them. And that's where you'll find that in math. Okay, you're not always going to just have an x squared. Don't be fooled by something like this where it says negative 15x squared equals negative 90. Don't be fooled and say, well, negative is there. It can't be done. You have to isolate the squared term before you can take the square root. I would not take the square root right now. I've got to get the x squared by itself.
Add 15.
Don't add 15, but
Add 90.
you got to divide by negative 15. We're undoing this multiplication. So I divide both sides by the negative 15, and I would get x squared equals a negative divided by a negative becomes positive. So that is going to have a solution. Now I can take the square root of both sides. And I would get x equals, can we break 6 down? 2 and 3, but will anything come out?
No.
So we just leave it as plus or minus square root of 6. Couple more. 2x squared minus 7 equals 38. Okay, we don't start out by taking the square root. We've got to isolate the squared term. So I would add 7. Okay, just like when we solved equations, we have to undo addition or subtraction first. That would leave me with 2x squared equals 45. Then I would divide by 2. Now, I'm not going to don't give me a decimal there again. No decimals. Right now it's just 45 over 2. Now I'm ready to take the square root. And how do we take the square root of a fraction from section 9.3?
45 over square root
Square
of 2.
root each of them.
Square root each of them. So square root of 45 over the square root of 2. Can I simplify either one of those?
45.
45 is 9 and 5, and 9 is 3 and 3. So the top of this is going to be a 3, and the 5 stays underneath. Can I leave my answer like that? No, you can't leave a radical in the bottom of a fraction. So you're going to times it by the square root of 2. So I'm going to move, I'm running out of space here, so I'm going to bring this up here. I would have 3 times the square root of 10 over the square root of 4. When I multiply that, that's going to be 3 square root of 10 over 2. And it's plus or minus. It's always a positive or a negative root or answer. That's where I leave that. This is why we had to spend some time on 9.3 simplifying radicals. Because sometimes you're going to get radicals when you use the square root to solve. Sarah, you got that one down?
I do. Thank you.
Okay, and then the last one I want to show you is when you have a quantity that's squared, like 7, and then the quantity x minus 3 squared equals 35. How I handle this. Okay, we're trying to isolate what's being squared. On all the previous examples, it was the variable, the x, that was being squared. What's being squared here?
X minus 3.
The whole group, the whole parenthesis group. So I want to isolate what's the parentheses. So I've got to undo the 7. I'm going to divide by 7. So I'm left with x minus 3 quantity squared equals 5. Don't try to multiply that out. You're just making more work for yourself. I'm trying to undo the squaring. The goal is to get x by itself, so I want to undo that squared. I'm going to take the square root of both sides. Remember, the opposite of squaring is to take the square root. When I take the square root of something squared, I'm just left with what was being squared. In this case, x minus 3 is left. On the other side, can we simplify the square root of 5?
No.
If we could, we would do it, but we can't, so it's just going to say plus or minus the square root of 5. Again, anytime you take the square root, it's positive or negative. It's plus or minus, 2 answers. Now at this point, you're not done, because x is not by itself. So you've got to add 3 to both sides, so that x is by itself. And the way that I write this, since we can't add a 3 to a square root of 5, the way I write this is I put the 3 first. It's positive, so it's going to be a positive 3. And then you just say plus or minus square root of 5. That is still 2 answers. If I took 3 and I added the square root of 5, square root of 5 is roughly 2.1. So if I took 3 plus that, that's 1 answer. And then if I took 3 and I subtracted that value, that would be my second. Both irrational values, but still values nonetheless.